I quite often get asked to put a video together that has everything you need to learn going into the A-level maths exams. So I'm going to have a go at it here. Hopefully I don't miss anything out. So let's crack on. So we're going to start off with coordinate geometry. So there are two things that I would really keep in mind. Okay, first of all is the equation of a straight line. Now you might think, oh, well, that's just y equals mx plus c. But the most useful version is y minus y1 is equal to mx minus x1. This is really the most useful version of the straight line equation. I use it all the time now. And secondly, that two lines are perpendicular when their gradients multiply together to make -1. Okay, two really useful facts there. Now for sequences and series, you are given the sum to n terms for arithmetic and geometric and the sum to infinity for geometric, but you're not given the nth terms. So for the arithmetic nth term, it's un is equal to a plus n minus 1d, and for geometric, it's un is a r to the n minus 1. Okay, you need to make sure you've learnt those. So it seems obvious that you should know the laws of logarithms, but here we go. Log base a of x plus log base a of y is log base a of x times y. And you've got log base a of x take away log base a of y is log base a of x over y. You've got log base a of x to the power of y is y log base a of x, so you can bring the power up and down as you like. And of course you've got log base a of a is 1 and log base a of 1 is 0. Okay, now you also need to make sure that you can convert from exponential to logarithmic form. So b to the power of x is equal to y converts to x being log base b of y. Okay, so you must make sure you know all the logarithm laws and also how to convert from exponential to logarithmic. Now you are given the constant acceleration formulae, the SUVAT equations, but when you're dealing with variable acceleration you can't use those. So you must make sure that you know which way you are differentiating. So the way that I always think about it is, if you remember that you write SUVAT down like so, then for variable acceleration it works in the same direction. So if you just think about ignoring the u, ignoring the t, you've got SVA. Okay, so displacement, velocity, acceleration. And what you need to do is you can integrate your way up, you're increasing, and you differentiate your way down, decreasing. Okay, so that's how you can deal with variable acceleration problems. Now with vectors, it always seems like there's a whole load of stuff that you need to learn, when actually it can be whittled down to a few basic things. First of all, that if you want to find a vector from A to B, then you want to have the position vector for B and then subtract the position vector for A. So AB is B minus A. That's the first one. The second point is a unit vector. Okay, so if you want a unit vector, it's usually written as the vector with a hat over the top. Okay, and the way to work that out is to divide your vector by its length. Ooh, like so. Okay, and what that does is it gives you a vector in the direction of A, but now of length only 1, of unitary length. Okay, and the last thing you're really going to want to make sure you remember is, with vectors you want to be able to find the length. Okay, so you know that in 2 dimensions that you would use Pythagoras. That's very obvious. In 3 dimensions, okay, so for example, if you had a vector that was 3, 2, 5, then its length is equal to 3 squared plus 2 squared plus 5 squared square rooted. So you're using 3D Pythagoras there. Okay, so you must make sure you know how to do that. Now, as for trigonometry, there's the trig identities that you must make sure you know. So you want to start off with that tan theta is sine theta over cos theta. Okay, so that's the starting obvious one. Plus then you've got sine squared theta plus cos squared theta is 1. Okay, so they're your first two. Now, in order to get the next two, you want to divide this second one through by sine squared, which will get you 1 plus cot squared is equal to cosec squared. Now divide this one through by cosine squared, you're going to get tan squared plus 1 is sec squared. Okay, so they are two new trig identities. Now, you're given the compound angle formulae, okay, but you're not given the double angle formulae, so you need to make sure you know how to find those or learn them. I would suggest always learning them. So sine 2 theta is 2 sine theta cosine theta. You've got cosine 2 theta, which comes in 3 variations. Either cosine squared theta minus sine squared theta, or if you replace the sine squared with 1 minus cosine squared, you get 2 cosine squared theta minus 1. Or if you replace the cosine squared with 1 minus sine squared, you get 1 minus 2 sine squared theta. And of course, you've also got tan 2 theta, which is 2 tan theta over 1 minus tan squared theta. Okay, so you've got those trig identities, you've got the double angle formulae. I would also make sure that you know how to convert from degrees to radians, obviously, okay? So always make sure that you know that 180 degrees is pi, and then you can make any conversion from there on out. Plus there are two triangles that I always suggest people learn. Okay, so you've got the two right angled triangles, so you've got the isosceles right angled triangle, 45, 45, 1, 1, root 2. Okay, that allows you to find sine of 45, cosine 45, tan of 45, using an appropriate triangle. And then you've also got 1, 2, root 3, with that one as 60, that one as 30, and that allows you to find sine, cosine, tan of 30 or 60. Okay, and so that's your trigonometry section. A continuing problem is always indices, okay, making sure that you know your indices. I probably should have done this at the start, but I'm doing it now, okay? So, index laws, you must make sure you know how to do those. I mean, there's always the very basic ones that I really probably shouldn't have to write down, like a to the m times a to the n is a to the m plus n. I'm sure you know that one. And I'm sure you know that a to the m divided by a to the n is a to the m minus n. Okay, these are reverses of the log laws. And also that a to the m to the power of n is a to the m times n. Okay, the ones that catch people out are things like a to the 1 over m, which is the mth root of a. And also that a to the minus m is 1 over a to the m. I'm still seeing students that have problems with the index laws, okay, even into the second year. So it needs a lot of rigorous practice to get it right. Now for sectors, it's very important that you learn the two formulae for arc length and area. So arc length is the angle times the radius. So remember, these are in radians, okay? And the area is equal to 1/2 theta r squared, okay? Those two you must make sure you learn. Okay, so differentiation, there are key derivatives that you must make sure you know. Okay, so if you are differentiating e to the kx, then that is k e to the kx. If you're differentiating sine of kx, then that is k cosine k of x. If it is cosine of kx, then that differentiates to minus k sine of kx. Okay, now tan of kx you're given, but I always think you should make sure you know it. Tan of kx is k sec squared of kx. Okay, you've also got log of kx, Okay, now that differentiates to 1 over x, regardless of that value of k as well, as long as k is greater than 0, okay? You get 1 over x because it's k over kx, and the k's cancel when you differentiate using the chain rule. You've also got, okay, if you've got a to the kx, so rather than e to the kx, a to the kx, that is equal to k log a to the x, a to the kx rather. Okay, so you must make sure you know how to differentiate a to the x. Now, you're not given the chain rule. Okay, so chain rule allows you to differentiate things like y is equal to f of g of x. Okay, so dy by dx, the derivative of what's inside comes outside. The exterior function differentiates, but the interior function stays the same. So you've also got the product rule. So the product rule is for product of functions, so y equals f of x times g of x. Okay, so dy by dx is equal to the first times the derivative of the second, plus the second times the derivative of the first. Okay, either way around. Okay, because that plus, it doesn't really matter. Quotient rule is given to you. Okay, so you don't need to worry about that. You just need to make sure you know how to use it. Now, I could do a whole section on integration, but I'm going to try and keep it onto this bit of the board. Okay, so first of all, you've got the e to the kx. We'll integrate to 1 over k e to the kx. Then you've got sine of kx. We'll integrate to minus 1 over k cosine of kx. You've got cosine of kx integrating to 1 over k sine of kx. Now, up here we had tan of kx, so that means that sec squared of kx integrates to 1 over k tan of kx. Okay, you've got the 1 over x. Now, someone's going to shout at me, so I'm going to put in the plus c's before someone puts in a comment, oh, why didn't you put the plus c's in? So we've got 1 over x going to integrate to log of x plus c, natural log of x plus c. Then you're going to have, you could also have this, what does a to the kx integrate to, I guess. So if you want a to the kx, then we would need 1 over k natural log of a to the kx. Okay? So the integration by parts formula is given to you in the formula booklet, so you just need to make sure you know how to use that. Integration by substitution, you are not given any hints to that, but you need to make sure that your first move for integration by substitution, you get u equals, right? And your first step, number 1, is find dy u by dx. Okay, that is always step 1. Okay. Then you've got things like changing the limits, and what have you for that. I would also make sure that if you come across any integrals that have things like 1 over, I don't know, x plus 1, x minus 3, that's partial fractions. Okay, so you need to make sure you know that. If you come across integrals of things like sine squared x or cosine squared x by themselves, this requires your double angle formula knowledge. Okay, so I've gone a bit too high. There we are. So you're either going to use either one of those. Okay, so that allows you to rearrange to get the sine squared in terms of cosine 2 theta, which you can integrate easily. Okay, now speaking of partial fractions, there are a couple of things you need to know. So let's say you've got 1 over x plus 1, x minus 1. Okay, this is the bog standard. You need to make sure you know that that can be written in the form of a over x plus 1 plus b over x minus 1. And if you had 1 over x plus 1, x minus 1, x minus 2, then that could be written as a over x plus 1 plus b over x minus 1 plus c over x minus 2. Okay, so this is the one where people start to get a little unsure of themselves. If you've got 1 over x plus 1 times x minus 1 squared. Now, you'll have the a over the x plus 1, that stays the same, but you're going to need a b over x minus 1 and a c over x minus 1 squared. Okay, so they are the formats of the partial fractions that you need to make sure you know. Parametric equations questions can be really tough, okay, but it really depends on the level that we're looking at, because they can range from very easy to very tough, as I say. Now, a few things that parametric equations you need to make sure you know. I would be looking at ellipses. Okay, so making sure you know the equation of an ellipse. So something like x equals 2 cosine theta, y is equal to 3 sine theta, for example, are the equations of an ellipse. The coefficients of the cosine and sine will have to be different in order to get you the ellipse, and it doesn't matter if the x has a sine and the y has a cosine. If the order is different, it doesn't matter. It's still going to be an ellipse. Okay, parametric differentiation. So dy by dx is going to be dy by dt times dt by dx. If t is your parameter, this is the connected rates of change, effectively. This is the chain rule. Okay, so dy by dt times dt by dx for parametric differentiation. You've got parametric integration as well. Okay, so parametric integration goes from y dx, okay, that's your bog standard integral, to being transformed to y dx by dt dt. Okay, so that is your parametric integration. One other trick that I would make sure that you know for parametric equations is that it can have a question where you're looking at the gradient of a line, okay, where all you know is the angle that it makes with the horizontal. Okay, if that's the case and you need to know the gradient of that line, then the gradient of a line is the difference in y divided by the difference in x. Okay, which for this right angle triangle is the opposite over the adjacent. Opposite over adjacent in SOHCAHTOA is tan, so the gradient of this line is actually the same as tan of the angle. Really useful to note that. So forces, we need to know Newton's second law, that the net force is equal to the mass times the acceleration. You're not given that. So consequently, weight is always mass times gravity. Okay, where the gravity could be given, depending on the question, as 10, 9.8, 9.81. The question will specify, if you're AQA, for other boards, look at the front of the paper, okay, if it's not specified. Usually it's 9.8. Okay, you've also got the friction and how that links with the coefficient of friction and the normal reaction force. So F, the friction now, I'll put that as FR, is less than or equal to mu times R. Okay, mu is the coefficient of friction, R is the normal reaction force. If the block, if a block is moving, then this is equal to. If it is on the point of moving, it is equal to. Okay, so that's how we can use that. Now for statistics, there's going to be things like how do you work out the mode, the median, the range, these are things I'm not going to include as their GCSE material. The mean, using sigma notation, you're not given. So x bar the mean is the sum of x, adding them all up together and dividing by how many there are. Okay. Now the standard deviation formula is given to you in the formula booklet. Okay. I would make sure that you know that the variance is the standard deviation squared. Okay. So the last thing I'm going to include in this video is about the normal distribution. Okay. And really the big thing that you aren't given for the normal distribution is the coding that allows you to get to the standard normal distribution, which is z is equal to x minus mu over sigma. If you don't know that, then you can't access any of the questions that need you to find a missing mean or a missing standard deviation, or both, which would use simultaneous equations. So this pretty much constitutes all the formulae that you need to know going into the A-level maths exams. I'm really hoping I haven't missed anything off, but hopefully the majority of this you already know, and there's just going to be a few bits that you will need to revise.